Hello. My name is Ray. I'm in charge of this undergraduate math curriculum for this year. And welcome to our event. We're going to have a LaTeX workshop given by Joshua, a fourth-year student apparently. And well, I guess we all know what LaTeX is, or else we want to be here. But yeah, let's start. Cool.
Yeah, thanks so much, Ray. Okay, so for those of you that don't know me, yeah, I mean, my name is on the board. My full name is Joshua Heckroodt. Everyone calls me Josh. I recommend you guys do the same. Please do not call me sir. I'm not old enough to be a sir. I'm only a fourth year. Now, that might seem old, but it's not. This is the second time that we're hosting this workshop, which means that I've gotten to learn quite a bit from the last time that we did this. So this time, the way that the workshop has been set up, we're going to be using Overly. So if you're just joining us, what you're going to want to do is, if you have your laptop at hand, which I sincerely hope everyone does, just go to, literally, if you just open up Google, type in Overly, it should be the first result. That's going to be the website that we're going to be producing all of our LaTeX on today. So I'm going to talk a little bit about the way in which I'm going to be kind of presenting this workshop, just from the point of view of kind of actually producing LaTeX code in a way that kind of everyone can follow along with. And then I'm going to say a couple of words about LaTeX, just kind of, yeah, as a tool for typing up mathematics. So LaTeX, strictly speaking, is technically a programming language. I'm always quite hesitant to describe it to people like that, because people who haven't programmed before tend to get freaked out when you start throwing, words like that in their face. But strictly speaking, it is a programming language. And as for any of you who have kind of had to grapple with learning a programming language before, you will know that it's a very hands-on experience. From the point of view of kind of the best way to learn how to do something is to try and mess up and basically figure out what not to do first. And we're going to be seeing kind of a couple of examples of where things can go wrong and how you can kind of, when things go wrong, discern for yourself, why has this happened? What can I do to fix it, etc. So that said, we're going to be, the aim of today's workshop is basically, I'm going to help all of you produce your, maybe some of you have used, actually, show of hands quickly, who of you have used LaTeX before? Okay. All right, okay, cool. All right, so some people will have a good idea of what's going on. But yeah, for the rest of you, I will be helping you kind of produce your first, possibly partially incomplete LaTeX document, because I don't know if we're going to get to the end of the entire document today, but I'm going to try my best, just in the interest of familiarizing everyone with different functions, or rather, kind of the most frequently used functions. So the document that we're going to be trying to produce today looks like this. I know it looks frightening, and for the people at the back, it probably looks like a massive blur. And don't worry, when I kind of switch to the web browser, I'll try and make the text a bit bigger so that everyone can see. Yeah, so this is the document that we're going to try and produce today. I know that there's a lot going on, many complicated symbols, integrals, roots, multiple different kinds of derivative symbols, blah, blah, blah. Don't worry, we are going to kind of unpack it all, and everything will make, hopefully, if I, host this workshop properly, everything is going to make perfect sense when we get to the end of the actual workshop. So just regarding kind of question, yeah, go ahead. You know what? I'm leaving that as an exercise. Actually, no, you have fun with it. I mean, I think so, but I don't know. I basically just picked this specific problem because, I mean, as you can see, there's a lot going on. Pretty much, so it comes down to it. So yeah, just kind of a couple of words in the way of the way in which kind of obviously we have this nice looking PDF, and then behind it is all the complicated stuff that many of you have come here to learn today. And so just a couple of words in the way of how some of that complicated stuff works. Like I mentioned earlier, LaTeX is strictly speaking a programming language, and it's a specific kind of language called a markdown language, which basically means that everything that you see on the page sits in what's called an environment. So if we look, for example, at this box here, right? So that'll be kind of a boxed environment, so to speak. If we look at this equation here, because it kind of stands on its own, separate from like a bunch of text and kind of anything else in the document, that will be a math environment. We have this block of paragraph text here, which is a paragraph environment, and so on and so forth. So one of the things that we're going to be familiarizing ourselves with today is kind of this notion of an environment. I'm going to show you guys a couple of examples of different environments, the most frequently used ones. And there really aren't that many, but we'll kind of jump into them nevertheless. Right, and then obviously kind of, when we're working within these specific kinds of environments, we have different, what LaTeX calls commands that we can use to produce different symbols. So for example, your integral symbols will have a specific command that when they're kind of input into this math environment, they show up as these kind of super neat integral symbols. And the same goes for, well, anything else that you can't find on a keyboard, really. So square roots, partial derivatives, really big brackets, etc., etc. Okay, so that's really all that I wanted to say in the way of how we're going to do the workshop, and just a couple of introductory words related to, this notion of environments and commands. What I'm going to do from here probably is kind of just immediately jump into it. So I've kind of cheated just a little bit in the sense that I actually, well, first of all, I'm already signed on Overly. You might see this screen if you've just created your account. If you already have an account and you've logged into Overly, you'll definitely see this screen. You're not going to have the exact same projects, obviously, but be that as it may. If you have just created your account, there's a chance that you'll immediately be greeted with kind of this blank sort of canvas, so to speak. If you're not greeted with that window, I mean, there's a big fat, new project button here in the top left corner. If you click that, it will just, you can click blank project and give it a name, call it name. And when you do that, it's going to take you to this screen. And you'll see that there is already some stuff on here. If this is the approach that you're following, do me a favor and just backspace all of it. Just get it. Because there's a bunch of kind of important stuff there that is definitely worth talking about, at least a little bit, before we immediately get into, how do I make my integral analyze. So I'm going to go, I've cheated a little bit because I already have this template document, as you can see. There is already some stuff in here. So if I open this, the stuff in here looks like this. Copy that down. That's not even a joke. I'm going to say a couple of words regarding what actually is happening here. But because we are all trying to, yep, noted. Better? Can everyone see? I think I can move this out of the way. Sorry. If the text is at any point too small, please just let me know. It's pretty easy to explain. But yeah, so kind of I know that it is I am kind of throwing you all into the deep end here by just kind of going get the copy this down. But we are going to talk a little bit about the stuff that you see here because there's already just in the little bit that's here a lot of useful information. So, but yeah, take a couple of minutes, and I think when I think everyone's done copying stuff down, we'll get going from there.
Margin is one point.
Question?
If they use packages,
Sorry?
but they use packages.
Yeah,
Can't you just like put them all inside one package wrapper?
you can. If you want to, you can definitely do that.
So I was wondering if like it would be fast.
Question? Yeah.
Why have you got square bracket online?
On this one,
Yeah, but then
I'll get there. Good question, but I'll get there. What's up? Question? What is this? All right. Okay, see, okay, fine, yeah. Actually, you know what? You're gonna mind if I just quickly wait until, actually, can I get a show of hands? Who's still copying?
Yes.
Are you gonna mind if I just wait until, yeah, I'll talk about all of it, don't worry, hold on a second.
You know what I've done wrong? Yeah, in my contact corner, it says
I have that as well, that is really just that after just happened. Yeah.
Why aren't those names?
Always. Yeah, it's used.
Never told me I'm hold on, let me finish typing down.
See, when I used to basically when this I had a list with screen like I don't think if you have to like basically you know oh, that's why. Oh, hey, there we go.
Okay, sorry, just quickly everyone's attention. If anyone is kind of running this and has hit recompile, or there's a setting where it does it for you automatically, and you get a bunch of just little words here that say lin, the reason as to why that's happening is because that's not an L, that's a 1. So change it to 1. Sorry. My bad. My bad. Yeah. Green tea and biscuits.
The biscuits I've got, just say.
Okay, show hands. You're still busy.
Oh, no.
Oh. Okay, fine. Is everyone good? Yeah, okay, cool. Okay, all right, so, right. Obviously, I've just given everyone a lot of things to type and a lot of stuff went wrong. And there's reasons for all of that. LaTeX is pays very, very close attention to the detail, which isn't all that surprising considering the fact that, like I said, it is technically a programming language. So what I'm going to do now is I'm just going to talk through some of, well, just what we see on the screen, right? So the first thing that you can kind of immediately tell is that every single line that I have on the page so far starts with a backslash, right? The reason for that is because every single command in LaTeX starts with a backslash. And this doesn't just go for things like, you know, when I'm talking about the format of a document, which is what I'm doing in this top line. It also goes for things like when I want to express an integral symbol, right? So for that, for example, would be \int, right? And so everything in LaTeX that you try and produce, whether it's kind of affects the layout of the document or the contents of the document, are going to be initiated by this backslash, which is a command. That said, obviously, all of these, well, not all of these, but most of these commands are different. The document class basically lets you pick what type of document it is that you're producing. We're producing an article today. We're producing an article. There are a bunch of different types of document classes. There's reports. LaTeX even has the ability to produce slideshows, which you've actually probably might have seen just because of everything going online. There are these nice blue slideshows that look very neat and tidy. But yeah, so the document type that we're working on today is called article. So that's passed into the curly brackets here. And you'll notice that this kind of theme is repeated pretty much throughout, well, every other command that we have here. These little things in the curly brackets are called arguments. And the arguments, when you're talking about the layout of a document, are going to be different arguments will produce different layouts. And in the same way, when we're talking about math symbols, different arguments will produce different expressions. So for example, when you're talking, like what I was saying earlier, I was talking about the integral command, and don't worry, this will all become clear as we start typing more. The integral command, for example, takes in as arguments the upper and lower bound of that integral, right? So that's kind of just to give you an example. These little things in the square brackets, they're kind of just, they're like extras, pretty much, right? In the sense that even within the confines of this article, we can still do things like dictate the font size. We can pick how many columns we want on the page, which is what we're doing here. We're saying we want 11 points or an 11-point font. And we're saying that we want one side, which basically just means that we're not going to have two columns, right? We're just going to have one column. The use package command, right, this one's quite important as well, just because it allows me to talk about packages. Packages in LaTeX, as you can kind of tell, are quite important. You know, they are quite a bulk of what we have here. And basically what they do is packages are like, there's a bunch of features built into LaTeX when you just kind of download it as it is, or when you use it on Overleaf as it is. And if you want extra functionality, right? Maybe you want to import some diagrams into your document. You want access to a wider range of mathematical symbols. You need to kind of, in a way, import what LaTeX calls a package, right? So, for example, this first one, we're saying use package graphic X, and this allows us to, like I said earlier, import, diagrams into our document, pretty much. So that's what this does. AMS Sim and AMS Math, these are two packages that give us access to, I mean, I've never really found a mathematical symbol that I needed that hasn't been included in these two packages. So with these two packages alone, we're going to be able to do everything that it is that we want to do today, right? This last one, framed, earlier when I was talking about that box environment that we saw on the page where we had this kind of statement of a theorem in a little box, that's what framed is, right? So framed puts boxes around stuff. Yeah, that's all there is to it. These three little commands here basically just dictate the author, title, and date of your document. I feel like that's quite self-explanatory. And if I leave them all blank, then what I get is, well, that on the right-hand side of you guys' screen, just a blank page, right? But if I go over and I put my name in here, put my name in here, so just, and I hit recompile, which takes your code and turns it into a PDF. That's really small. Anyways, yeah, then my name shows up, right? Means I am the author of this document. If I want to add a title, I can say, this is an example document. If I hit reconcile now, that's going to show up, well, slightly bigger because it's the title of the document, right? So this is how these things work. We have these commands. Question? Oh yeah, sure. Oh, okay, yeah, fine. So letter paper, right? This is basically dictating the actual like dimensions of the page that we're working on. So when I say letter paper, I'm talking about 21 centimeters by 27 centimeters, a sheet of paper. Yes, but basically the point of this command is that you can pass a bunch of different like sizes in here, and it will just resize your page for you. If you really wanted to, you could produce this document on a square page. I don't know why you want to do that, but it's theoretically possible. And then the last thing is if I chuck in the date, let's just say date. I hit compile, then that's going to show up with the date. Okay. Is everyone clear on that so far? Does that make sense? Yeah? All good? Okay. These two commands that we see here, begin and end document. Actually, sorry, not begin and end document, begin and end. These two are crucially important. When I was saying all of that stuff earlier about how much of what we actually kind of put into our documents is kind of included in specific environments, these are how we kind of denote or delimit our environments. So what I'm saying here is I'm beginning the document environment, and then at the end, I'm ending the document environment. And everything that goes into the document gets sandwiched between these two statements, right? Which means that everything that goes in between these two is inside the document environment, right? And we can see these environments reflected visually on our page. Obviously, that said, make title has to go in between these two brackets, because if I put it outside, then LaTeX simply isn't going to know that I'm trying to put the title inside the document, right? So this is kind of just an idea of how these different environments work, so, or rather how you can create different environments.
So how did it now put the author and the date in there as well?
Sorry? Oh, because so basically that's literally just because the command that's actually responsible for printing the title is this make title. It fetches information related to what it needs to put in the title from elsewhere. In this case, these 3 lines. And these 3 lines, well, okay, fine, they have to go before the document. Because the same way in which we, for example, like specify kind of what size we want the page to be, etc., we specify kind of other metadata related to the document kind of outside of these begin and end document brackets.
Right, but what you could say make or make date as well.
No. No, in a sarcastic way, just that's just how they do it. You know? Okay, so I'm going to momentarily click back to this document that we're going to try and produce. So if I take a look at what's going on here, I can see the title just says LaTeX workshop template document, and it gives my name. It's a little bit small on the screen, I do apologize. And then the first thing that we have afterwards is this kind of chapter thing, right? One followed by a problem statement, all in bold, slightly bigger than the rest of the text, right? Let's go back to Overly and let's see how we can do that. So I've now made my title, and I'm not going to be too particular about making everything look exactly the same as the document to demonstrate my goal. Underneath make title, I would like to include a section, or what LaTeX calls a section rather. So I'm going to do backslash, I'm going to type in section. This is the command that lets me, as the name suggests, specify new sections. And in here, you'd think that I would need to put the number of the section. I don't, right? LaTeX keeps track of that for you. That's one of the benefits of using LaTeX, the fact that you can just do stuff and it organizes it for you. So here I'm just going to type in problem. Once again, it's recompiled, and I'll see that problem statement has appeared on my PDF, right? Also, just as a point of convenience for anybody wondering, to the right of this this recompile button, there's a little drop down, and then there's this option that says auto compile. You can switch this on. If you do switch this on, then yeah. Is it anytime you change your document?
Yeah, every time you change it, auto compile will eventually.
Yeah, there you go. It catches up to you eventually. Yeah, there you go. So the point is that anytime you make changes to your document, you don't have to go back to a cursor, hover over it, click it, it just does it for you. Okay, cool. So that's one thing done. We go back here, you see, okay, now we have our first little bit of paragraph text. And this is quite important because it's what you're going to be using for just about, well, everything that you want to write in your documents, right, is going to be kind of just a paragraph. So the specific thing that we're typing up here is today we're going to be proving the following statement in LaTeX. And LaTeX is written really fancy because it's a super narcissistic programming language, but it actually has included a command that prints LaTeX like that. And we'll see it now. So in order to actually kind of start this paragraph text environment, I know that I was just saying all this stuff about begin and end, you know, being the things that start environments. Paragraph is a little bit different. It is kind of an exception to that rule. For paragraph text, we quite literally just do \var. We, as per usual, we need our open and close curly brackets, and okay, sorry about that. So as you'll notice, if I go ahead and put anything into this \var command, like for example, if I put in paragraph text, I've got auto recompile on, so it's going to recompile automatically. And when it does so, you'll notice that my paragraph text now appears underneath the section. Now, that said, okay, I was mentioning all of this stuff before about how LaTeX kind of just does stuff for you. The order in which you input your commands is quite important. So for example, if I was to swap these two around, then naturally the paragraph text would appear before the section, right? So I was going to type up what we said earlier. I said today we are going to be proving following statement in, and this is the command. It's quite literally /LaTeX in alternating case, and it shows up as that fancy thing there, which is kind of the LaTeX logo, so to speak. So that's fine. And now we can get onto some of the actual hats. Oh, come on. Okay, so you guys gonna have to bear with me. I kind of like to do it like this. I kind of prefer to keep my brackets on separate lines. The rest of my paragraph text just helps me organize the actual code itself. The code is just important as the output and the nuisance. Everyone happy? Yeah. So if I just return momentarily to the document, this is going to happen a couple of times, and then at some point I am going to just sort of switch over to, because I have it open on the side here, and then I'm just going to be going off of this, and you guys can trust me. So there's two things happening here. First of all, there's the box, which is, obviously quite a bit of an eyesore. And then there's another thing that's happening, which is that if you look at the paragraph text right here, this is on the left. If you look at the paragraph text here, it's in the middle, right? These are two separate environments. One of them puts stuff in a box. The other one puts stuff in the middle of the page, right? So from an actual, kind of going back to overly pointed, and we can go here. And what we can do is, and the order in this case is also quite important. But basically now we can kind of become a little bit more familiar with those begin and end commands, right? So the name of the environment that puts text in the middle of the screen is center, which I thought was quite a fun. Right, and so what we can do is, you'll notice that overly auto completes this for you, right? So if you just type in begin center and you can enter afterwards, it automatically puts in, sorry, let me scroll up just a little bit. It automatically puts in this end center, right? Because overly recognizes that if that's not there, you're going to run into problems. That's just how it is, right? And the name of the environment that puts stuff in, that's not how you spell it here. That puts stuff in a box is frame. And if I hit enter, overly is very kind and auto completes that environment for me as well. Question? Indentation in LaTeX does not matter. Okay. Everything can just hug this wall and it's going to run all the same. Or it can be way over there and it'll still be the same. Question?
Well, what's the difference between frame and frame? Because my auto sort of just showing frame. So
I don't know.
Okay, well, new frame doesn't.
Yeah, so this is kind of so this is also, I'm actually quite happy that you asked that question. So sorry, what's your name? Sean. Yeah. Okay.
I shot the sheet.
Right, okay. Sean has just asked me, he said that his overly auto suggested something to him while he was typing frame, which said begin frame without the D at the end, right? And his question was quite literally, what's the difference between those two environments? The answer, quite honestly, is I don't know, right? And this is kind of the point that I was making when I started off this session by saying that learning LaTeX is a very hands-on experience, right? In the sense that sometimes you're going to run into stuff that you're not quite familiar with, right? And you can test it out and you can, maybe it breaks, maybe you can figure out why it breaks, and in the process, learn something new about using LaTeX, right?
You guys think the order between search and frame is correct? Or is there some?
Actually, it is relevant. Yeah, you do need that. That has to be in that order.
What's it like tax things going like?
Surely it doesn't matter.
So in general, yeah. In general, yeah, it doesn't. No. In general, you're right. Things regarding kind of like the format of the document tend to kind of sort of wrap around things that affect the content of the document. Right. So here we're talking about we're putting a box on the document that obviously is going to show up on the document itself, but center affects how it shows up. Right. So layout environments tend
tangible things outside.
pretty much. Yeah, that's pretty much correct. Oh, sorry. Yeah.
Why does it work if I write center? If I write parking instead of it doesn't work.
Right,
Doesn't matter.
it's just American. I think it's just American. That's just okay. Is everyone good with that? Is that okay? Yeah. Okay. Okay. So in the box, if you think back to the document that we had, there was some actual maths in the box, which means that we're going to start working on actual maths. Right. So the specific kind of what I have written down was this, right? So we're talking about the volume V of a sphere of radius A, which is just a real number, even though it should be strictly greater than 0, that's my bad, is given by this equation here, right? So just an important thing to notice before I actually start typing more stuff, if you look at this equation, you'll notice that on the right-hand side, it's labeled, right? So this equation has a label. If you look a little bit further down the page, this one does not. These are two different environments, right? So this one is a labeled equation environment, this one is unlabeled. And from the point of view of typing it up, it looks as follows. So we are going to have let volume, and I'm going to do something that's going to look pretty funny to you now, but this is almost the backbone of this entire workshop. Dollar signs. And in between the dollar signs, I'm going to put the letter B. Now, single dollar signs like this, when you wrap an expression in this is inline mathematics, right? Which basically means that anything that goes in between here is going to be put on the same line as the text on the rest of the line, right? Which is why, if I look across here, it goes let volume V, and that V is in the same line as the rest of the line. Right? So that's where that comes from. And we will explore more kind of mathematics related environments like this one in the future. Also, just as a side note, yes, this is an environment. LaTeX has decided to use dollar signs to kind of denote this environment just because of how frequently it's used, right? I mean, the whole point of this language is so that we can type up mathematical expressions frequently and quickly. So they've decided to go with the dollar sign. That's just how they've done it. Now what we can do is we can go the volume V of a sphere of radius, right, okay? Now, the next expression that we had, if we think back to the original document, was A, which is just a radius, in the real numbers, right? So to do this, because it's maths, and because we're trying to put it on the same line as the rest of the paragraph text, we need our dollar signs once again. A, just on your keyboard. And now we need the symbol for in, right? Or is contained by the set, blah, 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 blah. And this is quite literally \in. Yep, there you go. It's a bit hard to see on my screen, but if you follow along with the code, it should show up on your screen. So that's the command for the in symbol, right? And so now we also start seeing how commands are used to actually generate kind of specific symbols, right? Not just intangible things like, oh, how big is our page, or you know, how big is our margin, what font size are we using, blah, 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 blah. You can use it to actually produce symbols. The next symbol that we're going to produce is the symbol for the real numbers. This looks as follows. So I'm going to do \, the word math, 2 B's, curly brackets, and an R in between them. And that is going to show up eventually. There we go. Okay, so this is A in the real numbers, right? The reason why this command looks like this specifically is because this \math BB just means the mathematics, it's called blackboard font, right? Or blackboard bold, rather. So that's kind of where this little abbreviation here comes from. And R, kind of if you put it in there, it basically is telling LaTeX print this using mathematics Blackboard bold font. If you're curious, yes, we could have picked a radius that's confined to the complex numbers as well. If it eventually updates, there it is. There's my complex valued radius, whatever. But we're going to stick to R. The next line is exactly, and now we need to give an expression for that volume V in terms of the radius A, right? So in order to do that, if you think back to the original document that we had that labeled equation, right? So perhaps unsurprisingly, I need an environment for the labeled equation. That environment is just called equation. It's going to break, don't worry about it. The only reason why that happens is because I have begin. Oh, no, it's fine. Okay. Wow. That's broken on every other software I've used. Okay. Overleaf is better. But you will notice that on the left-hand side, it's kind of yelling at you here a little bit, right? You've got these two X's on the side, and that's just Overleaf's way of telling you what equation though, right? And so it's just because we've left it empty. The specific equation that we're looking at, question. You can if you want to, yeah. It's completely, there's a lot of packages in LaTeX, there's a lot of packages that have overlapping features. And honestly, I think even just in base LaTeX itself, there's features, you really can go nuts, basically. Yeah, so the specific equation that we're typing up here is V, and that is equal to, and this is important because this is how you do fractions. Oh. Okay, all right. That'll be
Nick, what happened? You just turn on Oxford Power. Basically, like I think it tends to be it's like internet going bad or something. It shouldn't fix itself.
Someone joined the Zoom call and it broke over. All right, that's fine. That'll fix itself in a second. What's important is the actual what's on the left hand side of the screen. Sorry, I'll scroll up a little bit here. Okay, so fractions in LaTeX are done as follows. \frac is how we're going to do things. Now, obviously, with fractions, there are both numerators and denominators, and as a consequence, you would expect there to be two arguments, right? One for the numerator and one for the denominator, and that's exactly right. What we get is that the first argument is the numerator. The second argument is the denominator. Right, so it's going to update eventually, and when it does, you'll see a fraction. And this is how you do, well, any fraction. And what we also have for the rest of this formula is \pi, which is just a symbol for pi. As well as, okay, and there's also an important point. There's also an important point to make here. I want to type in pi a cubed, pi times a cubed. And if I just decided to put the a directly after my pi there, nothing shows up. Nothing shows up, and I get this little error symbol. And the reason why is because LaTeX no longer recognizes this as \pi. It now recognizes it as \p. All right, so to fix that, just the space bar there. Do indices. You just do this little, on my keyboard, that would be Shift-6. I don't know if that's British layout. It might be different for American keyboards, but you just need that little symbol there. And I can put it through. And then that. Right? So this is exactly the document that we were looking for so far. Okay, also just because we have roughly just over 10 minutes or so left. I realized that I did not end up getting through much of the document at all. But just while I have everyone's attention, there is a little stack of papers. I say a little because there's definitely not enough for everyone. what we'll do is we are actually going to keep one of them and we're going to put a pen out. I have these sheets. They look like this, right? This is the sheet. I have these sheets as PDFs. They are cheat sheets, right? So sorry, they are cheat sheets, right? So basically, all of the commands that you could probably ever need in order to kind of produce documents like this.
Wait, guys, going to rush it or figure out ways you cannot.
You might send that.
Yeah, you can find out.